right? So we've been working with algebraic expressions, and we've been working with the different lingo you need, like terms and variables and constants and terms, right? So now we're going to get into actual equations. So what we've been working with up to now have been expressions. So there's not really an equal sign, although in the last couple of examples I've been going over, there are equal signs because we're just simplifying things. So those simplified forms have been equal to the prior forms, the forms before. So now we're going to look at some properties of equality. So first off, what is an equation? Seems kind of like a really simple question, but it's an important one. It's an important one to make clear of. An equation is a statement that two expressions are equal. Okay, that's why you have your equal sign. Okay. Now sometimes you might see this. That means not equal. That's it. So this is not equal if it has a slash. This is equal when it is just the two lines. Okay. So now some properties of equality. And again, as with the other properties I went over 2 videos ago, when I mention A, B, and C, I am referring to variables that represent real numbers. Okay, so first off, we've got the reflexive property. Now, to remember this one, I just think reflexive, it reminds me of the word reflection. Like when you look in a mirror, you see basically the same thing. So that's how you can remember this one, because it states A equals A. So like 5 equals 5, okay? It equals itself, okay? And then you've got the transitive property. So you can remember this, I think of like maybe a train that transitions, it goes from different places, it gets from one point to another to another. You can think of it sort of like this, because it basically says if A equals B, then, let's see. Yeah, if A equals B, and there should be an and here, right? Because it's transitioning, it's not just 2 points. So, transitive property, if A equals B and B equals C, then A equals C. See, you go right from that first letter, that first variable, to another, right? You're transitioning, because these both have B in the equation. So you can just flip it out, right? Because you could substitute B, you could substitute B with A, and therefore you get A equals C. So for instance, if we say 2.5 equals 2 1/2, written as a mixed number, and we also say that 2 1/2 equals 5 halves, then we can use the transitive property to say that 2.5 as a decimal equals the improper fraction 5 halves, okay? You just transition really smoothly between that. But the important thing is you have to have these two equations where one side they do share, right? So like in both of these, they have 2 1/2 as a mixed number. So that is really important. Another one, symmetric property. So symmetric, you just think of flipping something between, say, like left and right, like opposites a little bit, but it's not quite. You'll see. So if A equals B, then B equals A. So if A equals B, then B equals A, right? So to recap so far, we've got reflexive property, which is A equals A, symmetric, which is A equals B, then B equals A. And we've got transitive, where if A equals B and B equals C, then A equals C. And the thing about this, let's say, so symmetric property, if I say 1/2 equals 0.5, then I can also say that 0.5 equals 1/2. Really simple, okay? And now, some properties for the 4 operations: addition, subtraction, multiplication, and division. So, I'm just going to put them all like in a little column because I think it'll be easier here. Addition, subtraction, because that's what we're going to talk about next. Addition, subtraction, multiplication, and division. All right, so the corresponding properties for those, if you have A equals B, so if A equals B, then A plus C equals B plus C. Now I will let you in on something. There is a very strong relationship between all of these, even though they're slightly different, and it has to do with keeping things equal, but you'll see what I mean, I think. So addition property, if A equals B, then A plus C equals B plus C. So let's say I had X equals 12, so that means X plus 3 equals 12 plus 3. Okay, now subtraction property, similarly, if A equals B, then A minus C equals B minus C. So again, if I have X equals 12, that means X minus 3 equals 12 minus 3. Multiplication, if A equals B, I feel like a broken record, then A times B, no, I'm sorry, not B, because B is on the other side. If A equals B, A times C equals B times C. Okay? So if X equals 12, then X times 3 equals 12 times 3. Now finally, division. If A equals B, then A divided by C equals B divided by C. The only circumstance, the only thing you need to make sure of is that C does not equal 0, because again, you cannot multiply, you cannot divide by 0. It's undefined. You try dividing by 0, a calculator is going to tell you it is undefined. So that's our example. So like if X equals 12, X divided by 3 equals 12 divided by 3. Now, notice, among these four down here, addition, subtraction, multiplication, and division, you know what the key relationship between all four of these is that whatever you do to one side of the equation, you have to do to the other to keep it equal. So notice here, if I add 3 on the left, I gotta add 3 on the right. I subtract 3 on the left, I gotta subtract 3 on the right. I multiply 3 on the left, I've gotta multiply 3 on the right. If I divide by 3 on the left, then I've gotta divide by 3 on the right. The point is, the bottom line is, whatever you do to one side of the equation, you have to do that same thing to the other side. Otherwise, you cannot say it is an equation, because it would not be equal. So, if you add to one side, you add to the other side. Point is, that is why it's equal, right? In their original form, they are equal. So if you change something on the left, you have to make that same change to the other side, period. So, those are the properties of equations, and in the next video I'm going to go over some examples as well as what it means to actually solve an equation that has a variable and not just like simplify it and combine like terms and all that. So, Maia out.